Today we'll be looking at programming with C++, as we already know. So, in this, we just first of all talk about a slight overview about the C++ programming language. Let's just give and go straight to the point. With our C++ programming language, it was created by our popularly known IT tech man, Bjarne Stroustrup, in 1979. The C++ programming language was formerly called C with classes. C++ was pioneered by Rick Machete in 1983, commercially released in 1985. The C++ programming language basically evolved from the C programming language in the mid 1998. ANSI and ISO C++ programming languages were approved. So let's get going. As we already said, we also learning why we should use C++ programming language. As you see here, the reason why we should use C++ programming language are being listed. And the first one we can talk about it. It's used in every computer system. Basically, currently in our modern day life, all our programs, all our robots, all applications being used to control AIs are basically written with the use of C++ programming language. And close to machine learning language, that system programming language makes it easier for the computer to understand. So here we'll be looking at why the use of C++, why we are supposed to use C++ programming language. As we said, it is used in every computer system. Normally in the life, most of our applications, most of our computer system and apps have the C++ programming language being their base codes and base structure of it. So when close to machine programming language. C++ has object oriented programming, and C++ is a compiled language. Universally stable, universally usable model programs. That it can be used across all sorts of applications and all sorts of things. You get me? Portable programs for various platforms. Okay. So on our next slide, we have object-oriented programming. With object-oriented programming, what can object-oriented programming be said to be? Object-oriented programming, which can be abbreviated to be OOP, can be said to be a paradigm that revolves around the concept of objects and classes. It's a very it's a way of designing and organizing codes to make it more modular, reusable, and maintainable. What are the key concepts of object-oriented programming? We have encapsulation, blending data methods that operate on that data within a single unit. Inheritance, creating a new class based on an existing class, inheriting its property and methods. We also have polymorphism, the ability of an object to take on multiple forms depending on the concept or the context in which it's used. Abstraction, hiding implementation details and exposing only the necessary information to the outside world. What are the benefits then of object-oriented programming? Object-oriented programming has modularity, easy to manage and maintain large code bases, reusability. Classes and objects can be reused across multiple applications. Easy debugging, that objects and classes can be tested independently, can be said to be the basic C++ input and output code, the basic form of a C++ program. Let's open our code blocks and test it out. This is our code blocks app. We have many C++ compilers. We have CLion. We also have Visual Studio, which can be used. We also have Dev C++, but I prefer using code blocks. So let's create a new project here first to test out our console application. Then we select C++. Then let's say ISO Welcome to the first tutorial. So see out, that's our ISO. I say allow the project to run. When I run the project, as the current code of written, when I run it, you see, it has given me what I type. Welcome, come to your first project, first video project. Okay, that's the software development kit. It's a collection of tools, libraries, and documentation that software developers can use to build applications for a specific platform, operating system, or software framework. As you already know, C++ has its standard line, and the compilation, the combination of the library and the headers and the functions all come up to form the SDK, that's the software development kit. Without that, you can't actually write a code for it to be processed or for it to be executed and understood by the computer. No, that's not going to be without that. And actually, we have types of SDK. We have the platform SDK, the software development SDKs, and the software, the operating system SDKs, and the software framework SDKs. We also have benefits of using SDKs with faster development, improves quality, increase productivity. We also have the loader which executes program into our main memory, and the last step is to execute the program. So this is the basic sequence of a C++ or a program to be executed. We have the C++ program, which first of all you need to have your editor to be able to write the basic code for it. Then you need a preprocessor. After the editor has done its part, then it's transferred to the preprocessor for it to do whatever it's supposed to do. Then the compiler, then the linker. But when you reach here, the standard library, which is an inbuilt set of functions, also comes in contact with the linker to be able to make use of the code you wrote for it to be able to be understood by the computer. The library comes in to help with that. After the linker, then it gets to the loader which will perform its job by loading it into the memory for execution. Then the final stage, which is the execution stage, the program is being run for you to see the output and the outcome of whatever you wrote in the program. Compiling and linking, as we already talked more about it, but let's rush through it. Run code through compilers. If compiler generates errors, you have to look at the code and remove errors. Run the code again through the compiler. If there is no syntax error, compiler generates equivalent machine code. Then the linker links machine code with system resource. See, it links machine code to system resource. That's the standard library. That's the system resource. It's having there. Yeah. And the loader and execution. Once compiled and linked, once compiled and linked, loader can place program into main memory for execution. That's what I said. The loader loads the code or the instruction or the task you want it to perform into the main memory for it to be executed. Then the final step is to execute the program. Compiler guarantees the program follows the rules of the language. So if you are to compile a program and to write up a code for a certain program and you do not follow the needed syntax or the needed algorithm, the compiler lets you know that whatever you are doing is out of the kind of programming language you are using, out of its league or out of its way of functioning, out of its way of arranging its code. That's what the compiler basically comes to know. Then the process the program loaded into memory along with the resources needed by the program. Each running instance of a program is a process. Each process runs independently. A thread is a unit of execution within a process. Multiple threads can be initiated from a single process. There are single thread processes and multi-thread processes. This is a basic diagram to represent the thread like this. So we have our big blue box to be the process. That's a single process. So within a single process, we can have multiple single threads and process info. The program starts out as a text file in the programming code. The program is compiled and interpreted into binary form. Then the program is loaded into the memory. The program becomes one or more running processes. Processes are typically independent of one another. Thread exists as subset of process. Just as the diagram explained more to us. Threads can communicate with each other more easily than processes can. So basically this brings us to the end of our first stay tuned for more.